Good morning, students. Today we are going to discuss A-level chemical energetics question. Okay, let us analyze the given data. The reaction of calcium oxide with hydrochloric acid. So they have given the exact stoichiometric equation for the reaction of calcium oxide and hydrochloric acid. Sometimes they won't give, but mostly in A level they will give the stoichiometric balanced equation. If they didn't give, we have to find out that one. So calcium oxide is a base and HCl is an acid. So when we are mixing acid and base, we will get the salt and water. In an experiment to investigate this reaction, the following procedure was carried out. Okay, something they have taken that 50 centimeter cube. That is 50 centimeter cube means it is in cc unit. That is 50 ml. It is in 50 ml, right? And then this one 2 ml. It's not 22 ml. Okay, and then okay. Here it is not mole ml, it is a molarity. Look at this, it's a molarity. Okay, so actually mole per decimeter cube is nothing but the molarity. Okay, then they have given the thermometer reading and everything. Okay, 1.46 gram of calcium oxide powder they are taking. Okay, and the temperature change they have given. So delta T we will find out. So delta T will be 35 minus 19.5. Not necessary to worry about the unit in the temperature scale when you are finding out the delta T. Delta T means change in temperature. Change in temperature can be in any unit. For example, in degree Celsius also, as well as in Kelvin also, you will get to the same change in temperature. So don't worry, don't bother about the reading. That is about the unit in that delta T case. So delta T will be 15.5. Okay, what they are asking, calculate the enthalpy change in joules for the quantities of this experiment. Assume that specific heat of the solution. So they are mixing CaO and 2HCl, and the reaction is CaCl2 and H2O formation, and then they are carrying out with the in the presence of solvent, right? So the total solution is having the specific heat capacity 4.18 joule per gram per degree Celsius. Okay, then we will check what they are asking. Energy transferred in joules. Calculate the enthalpy change. So enthalpy change in joules they are asking. So first enthalpy change in joules, Q you should find out. That is, in the case of A, we should find out that enthalpy change in joules for the quantities of this experiment. Assume that, okay, the enthalpy change, we are going to find out that one. So look at this, mass of the solution and the specific heat capacity of the solution and the change in temperature will be the formula for this one. The mass of the solution, we don't know. Let us check whether they have given the mass of the solution. 50 ml of hydrochloric acid, okay, concentration they have given, was pipetted into a polystyrene cup and the initial temperature uh, measured using a thermometer. Okay, 1.46 gram of calcium oxide powder was weighed and added to this acid. Okay, so what they have given, taken 50 ml of HCl they have taken, and then 1.46 gram of calcium oxide they have taken. So total weight will be, the total weight of the solution will be 51.46. So Q will be equal to 51.46 and the specific heat capacity will be 4.18 and the change in temperature will be 15.5. This will be the enthalpy change, that is due to the reaction. The water that are the solution is getting this much of heat energy. So 51.6 into 4.18 and then 15.5 will be 3343.16 joule we are getting. So this much of heat we are getting. Look at this, energy transferred in joules. They itself have given that formula. Look at this, 50. So they have taken that as 50. Actually, we are adding 51.6, right? But they have taken that as a 50. Okay, no issues. So actually, the exact value will be 51.6, but approximately they are asking us to take that 50. So I'm going to calculate. Not an issue. You can do that exact calculation. 51.46 is the exact weight of the solution, but they have taken that as a 50, so they are asking us to take it as 50. So I'm going to write that 450 into 4.18 into 15.5. So if they didn't give that formula, if they didn't ask us to find out like this, you should use the 51.6, because the total weight of the solution will be 51.6 after adding calcium oxide. After adding calcium oxide only, the reaction will be there. That's why I'm asking you to take 51.6, but they are asking us to take 50. That is approximately the size will be, that is approximately the uh, amount, that is mass, will be same. That's why 50 and 51.6, there will not be much more change. That's why they are giving like this. So 3239. So approximately we are getting the same heat. Don't worry. You can write, either you can give this value or this value. Both are right. Okay, and then this one. So calculate the molar enthalpy change of the reaction between the calcium oxide and the hydrochloric acid. So what they are asking, molar enthalpy of calcium oxide. So they are asking the delta H, that is heat energy released per mole of calcium oxide reaction, per mole of calcium oxide. So molar enthalpy change for the reaction between calcium oxide and HCl. So molar enthalpy change they are asking. So if 1 mole of calcium oxide we should take, let us check whether there is 1 mole of calcium oxide only in the stoichiometric equation. Yes, we are having 1 mole of calcium oxide, but we are using 1.46 gram of calcium oxide, right? So 1.46 gram of calcium oxide. So 1.46 gram of calcium oxide neutralization releases this much of energy. That energy has been used to raise the temperature of the water, right? Now they are asking the molar enthalpy of CaO. So 1.46 gram of CaO is giving this much of energy. Now I'm going to give you 1 mole of calcium oxide weight, 40 plus 16, 56. So 56 gram of calcium oxide will give how much energy? 3239.5 into, just a cross multiply, 56 divided by 1.46. So what we are getting, let us check that one. 56 divided by, you will get the calculator, right? So do the calculation in the calculator. So finally we are getting 12,000 and I'm sorry, 1,24,254.7. So approximately, if it is in joule, if they are asking in kilojoule, then you should write your answer. That is, you should write your answer in kilojoule, means it will be 124, approximately 124 kilojoule. Okay, here once again I am just giving the glance about this question. Here first we are carrying out this reaction. This reaction will release some energy. Neutralization always release some energy. That energy has been used by the solution, and the change in temperature happened due to that energy gain by the solution. Actually, this reaction release energy and the solution gains energy, and the gain energy has been used for the change in temperature, rise in temperature. So we have calculated that change in temperature. We have calculated that energy by using the change in temperature. So you can use 51.46 as well as 50. Actually, 51.46 will be the exact one. But 50, they are asking us to take that as 50 itself. Even though they are adding 1.46 gram of calcium oxide after getting that 50 ml of hydrochloric acid, they have taken that as a 50. That may be considered as, that is the volume of the solution have a lesser density, that may be that may have a 50 gram weight. Even 51.46 gram of the solution, that is 51.46 ml of the solution, may be equals to 50. That data they didn't give, but simply they are asking us to take 50 gram. That's why I have used 50 gram. Not necessary to bother about this one. You can take either 51.46, both are right because the density is not given. So both answer will be the right one. But they are asking us to take as 50. That's why I have taken that equation, that is, I have taken that gram as 50. And then finally I have found the heat energy that has been gained by the solution. That energy will be coming from the neutralization of calcium oxide and hydrochloric acid. That's why I have used 1.46 gram of calcium oxide for that energy calculation. And then 56 gram of calcium oxide will release this much of energy. Why I have calculated for 56? Because 1 mole of calcium oxide will be equal to 56 gram. 1 mole is nothing but the weight of 1 mole of any compound will be equal to molecular weight. That's why I have added that atomic weight. So 1 mole of calcium oxide is 56 gram. That is molecular weight of the calcium oxide. So per mole means 56 gram calcium oxide will release this much of energy. Hope you have understood this one. If you couldn't able to get that, you please send me your doubts to my WhatsApp number. Thank you, students.